Hi, I'm Mackenzie, and today we're going to learn a little bit about the history of hockey and the physics involved. So let's get started. Hockey is a game that is slowly but surely growing in popularity in the United States, but has been around for a very long time. Historians believe that it began as a ball and stick game played in Persia, Egypt, or even China, and traveled to Greece in the 1400s BCE. As civilization changed, so did this ball and stick game. As civilization moved to the north, this game transitioned from being played on the dirt to be playing on ice. It is believed that hockey comes from a mixture of the Dutch playing a version of golf on ice, Scotland men playing hurling on the ice, and the North American Indian game that is now referred to as lacrosse. Until the late 1800s, the game that we now call hockey was played only in small towns and had no organized setting. In 1872, a man from Nova Scotia named James Crane moved to Montreal and brought with him boots with rounded blades attached by metal clamps, which served as the first pair of hockey skates and a couple of hockey sticks. Back then, hockey was viewed as an outdoor sport only because the idea of having a ball flying around inside was unthinkable. To solve this problem, Crane took a flat, circular piece of wood and turned it into the first ever hockey puck. The first ever public hockey game was played on March 3, 1875. The sport was praised, but the violence of the sport was noted. As time went on, the game continued to grow, popularity increased, and the rules were altered until it is now the same game that we participate in now. What started as a small little pickup game in Canada is now a game that is enjoyed by millions throughout the world and is growing bigger and bigger every day. I first fell in love with the sport of hockey at the age of 9. As a Christmas present, my parents bought me and my brothers our very own ice skates. After Christmas that year, we went up north to our cottage, and my dad spent about 2 hours clearing off snow on the lake to make a little ice rink. He sat down in disbelief when my brothers and I chose to skate on the part of the lake that was still covered in snow because it hurt less when we fell down. That night, my dad had to come outside with a flashlight and physically pull me off the ice because it was time to go to bed. Soon after that, my parents enrolled me in a learn-to-play hockey program at a local ice rink, and I fell more and more in love with the sport. I entered into a house program, and from there I went to the AA travel hockey level, and finally to the AAA hockey level, the highest level for amateur hockey. Hockey has taken me all around the U.S., from Minnesota to represent the state of Michigan and Michigan Youth Hockey, to Wisconsin, Indiana, Ohio, Maryland, New York, Boston, Vermont, and all over Canada. Hockey has helped me to make memories that I'll never forget and to create bonds that will last a lifetime. Hockey has even helped me pick the college that I will be attending in the fall, as I will be playing collegiate hockey for Adrian College next year. So now that we know how hockey started and why it is important to me, time for the physics of hockey. Sir Isaac Newton is arguably one of the most knowledgeable people of the sport of hockey, and here's why. Newton's laws of motion. First off, we have Newton's first law of motion.
Wish I could reach up and reset that sun. Reverse these wheels, go back and re-pick you up.
If you set a puck down on the ice, it will not move. In order to get the puck moving, an unbalanced force, which in this case is the hockey player and their stick, has to strike the puck, forcing the puck to move. If there was no friction or boards on the rink, after the puck was hit, it would go in the same direction at the same velocity forever. And now we are going to learn about Newton's second law of motion.
Oh, I float the moon back up in the sky. Put a cord back into that sweet red wine. Put your midnight hair back up so you can let it fall one more time.
This applies to hockey because of the differences in the strength of each shot. A slap shot delivers far more force than a wrist shot does. This is because a hockey player winds up to take a slap shot, increasing acceleration. There is no wind-up to take a wrist shot, and therefore no increase in acceleration. And since the mass of the puck is constant, there are differences in the amount of force from each shot. To end, we have Newton's third law of motion.
Untouch your skin, unkiss your lips, then kiss them again. So good, so right. This is one night I'm wishing I could rewind.
Newton's third law of motion is most easily seen in a hockey player's stride. They push into the ice at an angle that is behind them, and as a result, they are propelled forward. Newton's laws are just some of the many ways that physics is involved with hockey. I hope you enjoyed this video and have a good summer.